think you have learned this at high school about moments, but at high school you typically write it like this. But at university, in this course, we need to write moment as R cross F. Okay, R is in the front and F is in the back. And now R is of course moment is this one, and this is force, and this is called you know the name in Chinese, and the English name of it is moment arm. Now, and for describing the moment arm, because this moment is with respect to point O. Point O is here, and the force is acting on point A. The force is acting on point A. So the moment arm goes from goes from O to A. So there are three ways of writing it. We have these three methods are the same. You can write OA. You can write ROA or RA with respect to O. These three methods are the same. Now, of course, I'm happier if you write in these two ways, and it's zero. And moments can be added as long as they are going through the same point. Moments can be added as long as they go through the same points. And if the moment arm and both the moment arm and the force are written down in I, J, and K, we can determine M, that is R cross F, using the determinant. And in the first row, these are I, J, and K. And then the second row is R, and then the third row is F. Please keep the right order. Please keep the right order, and in order to do things correctly. So is that okay? So this was what we discussed on Thursday. Now the next thing is the sometimes we don't want to we want to determine the moment about another point. For example, MB. Let me have a quick. Let me sketch. X, Y, and Z, and then, for example, if we have a force, the force is acting on point A, and then that is point O. And now we have point B here. Sometimes, of course, we know how to determine moment about O, and this is the force acting on point A, and where is the moment arm? Moment arm goes for this one. For the first one, for MO, the moment arm goes from point O to point A. Okay. For the moment, this is the moment arm. This goes from point O to point A. Therefore, on the screen, it is this one. Is that? I think it is. We are just repeating the calculation, the writing we wrote on Thursday. It's okay. Now, sometimes we don't. We want to determine the moment about another point. For example, point B, but not point O. Of course, we know point O. We know M with respect to O, but sometimes we want to know the moment with respect to point B. Now, the moment arm is then. The moment arm for this one is then. Sorry, let me use another one. This one. So for this one, for M with respect to B, sometimes then we can that is our moment arm will be this one. With respect A with respect to B. This is, I think this is easy for you, but sometimes it is not always easy to determine this one. As I will show you some examples. Sometimes it is not easy to determine the vector from B to A. Therefore, we can use addition and subtraction of vectors to make it like this one. So this one is how B with respect to O, and you can see that this one is equal to our A with respect to B. This should be clear enough. But I'll use this equation to show in a future example, in an example, I think next week or in 2 weeks time. So it's okay. So the most important point, let me repeat, the most important point on this page is that in writing moments, we write the R in the front and F in the back. Okay? So if you are okay, then we go on to the next page. Sample problem 3.1. And a vertical force is applied to the end of a lever, and which is attached to a shaft at O. Determine these four things. First of all, is the moment of the 500 Newton force about O. The second is the horizontal force applied at A, which creates the same moment about O. And the third thing is the smallest force applied at A, which creates the same moment about O. And the part D is whether the forces obtained in B or C is equivalent to the original force. I think the verse should be clear now, and I think the first part A is quite clear, and determine the moment of the 500 Newton force about O. So the force is this one, and the moment arm goes from O to A. Now, and this is a 2D. This is a 2D problem, and this is a 2D problem, and therefore, we have M with respect to O equals to R times F times sine theta you can write theta here, or you can write sorry. The theta should be here. Now, this one is, I think you've learned this in high school, so let me go through it quickly. And this one is 150 degrees. If you make it as 30 degrees or 30 degrees, the result should be the same, and I don't think there is any problem. So in this problem, and R equals to the moment arm is equal to 0.6 meter, and F equals to 500 newtons, and theta equals to 30 degrees or 150 degrees. Therefore, MO equals to 0.6 times 500 times sine 30 degrees equal to 150 Newton meter. And in the textbook, moments are marked in these two directions. In the book, so it is good to do. It is good to do this. How should we say these two in English? Any idea? Okay, so this is clockwise, and this is anti or anti-clockwise. Okay. Now let the horizontal force be F prime. Now, now MO is equals to R times F prime times sine 60 degrees or 120 degrees. and f prime is equal to 288.5 Newton. Because this one is equal to 150 Newton, right? Newton meter, right? Remember, if we write a force, we need to write the direction. Is the answer. And then we come to part C. Now we come to part C. What do we need to determine in part C? In part C, we want to find the smallest force applied at A, which creates the same moment about O. And smallest force. Now we have the same equation, right? We have the 150 Newton meter equals to R times F double prime times sine theta. R times F double prime times sine theta. Now, take your time to write it down. Now, if we want to find the smallest, because this one is fixed, and R is equal to 0.6 meter. So if we want to have a the smallest F double prime, it means we need the largest sine theta, right? So sine theta is maximized when theta is equal to 90 degrees. If F double prime is minimized, sine theta is maximized, therefore theta is equal to 90 degrees. Therefore, F double prime equals to this one. I'll give you time to write it down. Okay. So now what is now the first three parts should be easy to you, and about the last part, whether the force obtained in B or C is equivalent to the original force. Now, let me make it smaller. In part B and part C, we have fixed the moment is the same. The moment is the same, but the forces are different. In part D, is the are we talking about the moment or the force? We are talking about the force. We are talking about the force. So if we say forces are equivalent, and what does it mean? If the forces are equivalent, that we have two points to study. Let's go back to page 21. F and F prime are equivalent if the magnitudes are the same and the lines of action are the same. Okay. So we go back. So this is based on notes page 21. Two forces are equivalent if both the magnitudes and the lines of action are the same. But here in parts A, B, and C, the magnitudes of the force are all different. The original one is 500, and in part B we have 288, and in part C we have 250. So all the magnitudes are different, and of course the lines of action are different. Therefore, the answer is no. Because the magnitudes are different. One trick or one tip in answering questions. In part D, the question is about yes or no, whether blah 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 blah, or is it blah 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 blah. So if you want to answer this kind of question, please write it down whether you say yes or you say no. Okay. Otherwise, I don't know what you are saying. So in this question, the answer is no, and because and then you write your reason. Is that okay? Now, after a 2D problem, we go to a 3D problem, and the 3D problem is sample problem 3.4. Now, and of course, the keyword here is to determine what do you need to calculate. The moment about A of the force exerted by the wire on point C. So the point of reference is here, this one, and then of the force exerted by the wire on point C. So the wire goes from point C to point D. Therefore, we have two forces. We either have this one or we have this one, right? If we are talking about the tension, we either have this one or we have this one. The question asks you about the force acting on point C. Exerted is X. Now, therefore, we have, so this is not the thing we are talking about. We are talking about the force acting on point C. This one. And the tension in the wire is 200 newtons. Now the problem is quite clear, and we want the point of reference is point A, and the force is acting on point C. Therefore, the moment arm goes from point A to point C. Right, and then the rest is should be easy. Now, the coordinates of points A, C, and D are these three. Therefore, the moment arm is RC with respect to A equals to RC minus RA, which is 300 I times 0J plus AC K millimeter. Because we are determining MA, and MA is equal to R cross F, and now if you let me keep this. Now if you if you don't know what to write in the quiz, at least you can write. If I ask you about to determine the moment about some points, at least you write this one. I will not give you 0 mark. Okay. So write this down first, and then this is what we want to know. MA is what we want to know, and then we have we can determine this and determine this in 2 steps. Now we first determine the moment arm here, and then the next one we determine the force vector T. Now we know the magnitude of T is 200 newtons. This is tension of the wire. But how should we determine T as a vector. How should we determine T as a vector? Now it goes back to page 16, I think. Yeah, page 16. No, page 16. Yeah. And now we go to next page 16. The SOP I'm talking about is this one. So we know the force goes through points M and N, and we want to determine, and we know the magnitude of the force. We know the magnitude of the force, and we know the 2 points on its line of action. Therefore, we have this SOP on how to work out how to determine the force. The force vector. Is that okay? This is on the point page 16. Page 16, and we have an example on page 17. Page 17 is here. So there is an example. Is that okay? So for solving the problem on the page 24, we have notes page 16 and page 17 as example. Now to give you a summary, and we want to determine the unit vector in the direction of CD, which is let me give you the answer at 2.6 I plus 0.48 J minus 0.64 K. This is the unit vector in the direction of CD, and how to determine this thing, and please go to pages 16 and 17. Okay. Now suppose we know the unit vector of in the direction of CD. Now if T is equal to 200 times which is equal to now for the last part, because M equals to R cos F, and in this case F is equal to T. What did I write there? T, yeah. Now the last thing is to determine MA, moment about A, and this is equal to R C with respect to A times T, which is okay. That's the key thing I want to remind you. It can be calculated using this determinant. It can be calculated using this determinant. And what should we write in the first row? IJK, very good. IJK. And then the second row, what should we write? R, Rx, Ry, and now Z. So we have 300 and 0 and 80. This is our individual. Now the third row, the bottom row. In the bottom row, we fill in the forces. Therefore, MA equals to this one. Remember, the key point is to fill in these 3 rows in correct order.